Okay, let's talk about limiting reactants, theoretical yield, and percent yield. If you're making pancakes and we only have 2 eggs, but I have, let's say, 3 bags of flour, which ingredient will limit the number of pancakes that I can make? Eggs or flour? Well, it would logically be eggs because I only have 2 eggs. I'm going to run out of eggs before I can make any more pancakes. Okay, so we're going to call the eggs our limiting ingredient, or in chemistry we call that the limiting reactant. Okay, the amount of pancakes that I can make with my 2 eggs, that amount of pancakes is also known as the theoretical number of pancakes that I can make. And in chemistry, we call that the theoretical yield. Okay, so the limiting reactant is the one that gets completely consumed, and the theoretical yield is the maximum amount of product that can be made with that limiting reactant. Okay, and we typically calculate the theoretical yield. It usually isn't given in a problem. Okay, the actual yield is the amount that you do produce. So a lot of times, if we do an experiment, they will give you an actual yield, and if they give you the actual yield, we usually use it when we're calculating something called percent yield, which I'll also show you in this video. So let's take a look at example number 12. So I'm going to write out the balanced chemical equation. It's 2 aluminum combining with 3 chlorine to give you 2 aluminum chloride. It says if we begin with 0.552 moles of aluminum and 0.887 moles of chlorine, what is the limiting reactant and theoretical yield of aluminum chloride in moles? Okay, so when they give you, now listen to me carefully, when they give you the quantities of 2 reactants, it is a limiting reactant problem. They want you to do double the work to figure out which one produces the least amount of aluminum chloride, and then that reactant is your limiting reactant, and then the amount produced is your theoretical yield. So what we're going to do here is we're going to do 2 one-step problems. I'm going to take 0.552 moles of aluminum, and I'm going to do a one-step conversion using the coefficients. So we're going to take 0.552 moles of aluminum, do a mole ratio of 2 moles of aluminum to 2 moles of aluminum chloride. Those 2's cancel out. You're going to get 0.552 moles of aluminum chloride. Okay. Then what you're going to do is the same thing with the other reactant, which is 0.887 moles of chlorine. So I'm going to put 0.887 moles of chlorine here. And I've got 3 moles of chlorine for every 2 moles of aluminum chloride. So it looks like this. Okay, 0.887 times 2 divided by 3 is 0.591. Okay, so now, which reactant, aluminum or chlorine, produced the least amount of product? Well, it was my aluminum. Aluminum only produced 0.552 moles. That's less than 0.591. So that means the aluminum is my limiting reactant. So I'm going to make a little arrow here, and I'm going to write that this is my limiting reactant. Okay? Since aluminum produced the least amount of product, that least amount of product is known as the theoretical yield. So let's make a little note here. The 0.552 moles of aluminum chloride is the theoretical yield. Okay? All right, now, there's a second part to this problem where they ask us to calculate percent yield. They say if 0.693 moles of aluminum chloride are produced, that means that's how much I made in the lab during an experiment. What is the percent yield? Okay, so percent yield, by definition, is the actual yield divided by the theoretical yield times 100. Okay? The actual yield they gave us is 0.693 moles. So I'm going to put that up on top. And then the theoretical yield is my 0.552 moles. Okay, so we're going to take 0.693 divided by 0.552, and then we're going to multiply it by 100. We miraculously get 126%. Okay, now either you're a rock star in the lab or it's totally contaminated. I tend to think it's totally contaminated. Okay? Okay, so that's how you do limiting reactant problems and percent yield. So we've got one more sample problem, so I'm going to erase this. And we'll take a look at example 13. And I'm going to write out the balanced chemical equation first. Which is this. So when 11.5 grams of carbon, so I'm going to write 11.5 grams underneath carbon, are allowed to react with 114.5 grams of Cu2O. So we're going to write 114.5 grams under Cu2O. 87.4 grams of copper are obtained. Okay, now that number is your actual yield. So what I'm going to do is down here at the bottom, I'm going to write percent yield. 87.4 grams is going to go on top. We need to solve for the theoretical yield, which is going to go on the bottom. But we haven't calculated that yet. Okay. Find the limiting reactant, theoretical yield, and percent yield. Okay, so I'm looking for the grams of copper that can be produced from those quantities of reactant. So I need to figure out which one is my limiting reactant first, and then I'll know what the theoretical yield is. So we're going to convert grams to moles, and I'm going to try and write small here. The molar mass of Cu2O is 143.10. And then the molar mass of carbon is 12.01. Okay, so 114.5 divided by 143.10 is 0.800. I'm just going to leave those numbers in my calculator. Okay, and then we have to do a mole ratio from Cu2O to Cu. So I've got 1 Cu2O for every 2 Cu. So we're going to multiply that by 2. And I should have written moles after 2 moles of Cu and 1 mole of Cu2O. I just don't have the room here. So 1.6 moles of Cu. Okay. And then you have to multiply by the molar mass of Cu, which is 63.55. So I don't want to rewrite this. So times 63.55, 101.7 grams of Cu, okay, for the first one. All right, now for carbon, 11.5 divided by 12.01. It's going to give you 0.9575. Okay, then you have to do a mole ratio. So it's 1 mole of carbon for every 2 moles of Cu. Okay, so we multiply that by 2. 1.915. So 1.915 moles of Cu times the molar mass of Cu to get you into grams, so times 63.55. You're going to get 121.7 grams of Cu. Okay, so which reactant produced the least amount of copper? It was the Cu2O, because it produced 101.7 grams, which is less than 121.7. So up here, which was my Cu2O, this is my limiting reactant, okay? And then the 101.7 is my theoretical yield. So since that's my theoretical yield in grams, we're going to put it down here because percent yield is actual divided by theoretical times 100. So 87.4 divided by 101.7 times 100. And you're going to get 85.9% for your percent yield.